Welcome everyone to the next phase of the course where we're going to be learning about unsupervised machine learning methods. So it's time to begin shifting gears and going from supervised learning to unsupervised learning. And in general, this really is a paradigm shift from our previous discussions and previous machine learning algorithms. If data science and machine learning is a mix between an art and a mathematical science, unsupervised learning is where we're really going to dive deeper into the art aspect, because it's not going to be completely clear what the right answers are when it comes to unsupervised learning. So let's discuss the main differences between supervised learning and unsupervised learning. Recall that with supervised learning methods, we were using historical labeled data, and then we wanted to predict a label on new data. And that label could be something like regression, the price of a house, or it could be something like classification, classifying whether or not a tumor is benign or whether it's malignant. Now, let's think about what unsupervised learning is. We're going to end up using unlabeled data, which means we technically don't know the right answer. We don't have that Y label to work with. It's just features. So we're going to work on understanding how to discover patterns, clusters, or significant components. So in general, when we're talking about unsupervised learning, in the same way we split supervised learning into classification and regression, we're going to split our understanding of unsupervised learning into clustering and dimensionality reduction. In clustering, we're going to use features and try to group together data rows into distinct clusters. We can almost think of this as trying to discover a correct Y label when we're not given one. The next phase of unsupervised learning we'll discuss revolves around dimensionality reduction, which is going to be, again, using features, discover how to combine and reduce into fewer components, and see if that gives us some sort of deeper insight into the data. Notice that whether it's clustering or dimensionality reduction, I used the features. And that's pretty much what I have to do, because with unsupervised learning, we will not have that Y label. There's nothing to actually compare it to see whether or not we got the right answer. And this is where the paradigm shift really comes into play from transitioning from discussing supervised learning to unsupervised learning. All those performance metrics we learned about in supervised learning are not going to be able to apply for unsupervised learning. And it really has to do with this fundamental question. How can we actually compare to a correct label answer, such as the correct historical price a house sold at, if there was no label to begin with? Recall that we go into unsupervised learning because of the very fact that we do not have that Y label to begin with. So instead of metrics like root mean squared error or accuracy, we're going to need to figure out other ways of assessing unsupervised model performance, or in reality, how reasonable is this model? And even our understanding of what performance actually means will need to change with unsupervised learning. We're not going to have these really nice and easy to use metrics like we did with supervised learning to put a rubber stamp on our model and say it's okay to be deployed. Unsupervised learning has a lot more nuance than that. So let's talk about this in regards to our machine learning pathway. What does our machine learning pathway look like with unsupervised learning? Recall that we need to start off in the real world. And then we collect raw data from physical sensors, surveys, simulations, etc. And then we need to process and store that data, either in a SQL database, CSV files, Excel, cloud storage, and all of that we can say is just collect and store data. That actual process is not going to change. But keep in mind, when it comes to unsupervised learning, this is going to be unlabeled data. For example, maybe you collected a bunch of emails and no one's actually labeled those emails spam or ham yet, like we saw in the natural language processing lectures. We just have the raw emails themselves completely unlabeled. Well, we can still clean and organize data, and we can still perform exploratory data analysis. Since these datasets are going to look very similar to the previous datasets, except there's no Y label. It's just X features. And because it's just X features, that means we're not actually going to be able to train a supervised learning model on this because there's no Y label to train on. So instead, when we go to the machine learning models, we're not going to predict an outcome, but instead with unsupervised learning, we try to discover patterns in the data. And this is where we perform that split of two different types of discovery of patterns. We can either try clustering or dimensionality reduction, or technically we can do both. So let's talk about clustering first. Clustering, in the case, if we have unlabeled data, the question we're trying to answer is, can we attempt to cluster or group together similar data points just based on their features to try to discover possible labels for clusters? So I can take these rows and rows of data with all their X features and say that, hey, these data points seem to be pretty similar to each other, and then there's another cluster or group of data points that also seem similar to each other. And now I'm starting to separate this out into clusters. But keep in mind, I don't actually know the correct Y label like I did with classification. Instead, I'm essentially trying to discover this Y label. And I won't actually know if this is the correct methodology because I don't have that Y label to begin with. Then there's dimensionality reduction. So again, if we have unlabeled data, can we actually attempt to reduce the number of features by combining them into new components? And do these new components give us further insight for the data? So often, you're going to be dealing with really large data sets with many features. And for a human to actually discover insights into the data, having something like 25 features is really unwieldy, and it's hard to actually understand what are the important features or how the data is actually dispersed between groupings or clusters. And with dimensionality reduction, what you can do, and often dimensionality reduction is combined with other machine learning methods, is you can combine different features and create new components out of them. And then maybe you can reduce from, for instance, 25 components all the way down to 3 or 2 components, which you can then actually plot out and have a human readable format with this new component set. And we'll be learning about things like principal component analysis in order to perform dimensionality reduction. So we will start off, however, with clustering methods such as k-means clustering and hierarchical clustering, and then move on to dimensionality reduction. And keep in mind, we will actually learn about methods for interpreting the model results, but results and performance is much more nuanced in supervised learning. We'll never get this really nice, clean metric of 100% accuracy or 10 root mean squared error, but there are methodologies to actually evaluating reasonableness or performance of unsupervised learning metrics. But keep in mind, we will have to kind of shift our understanding of what our performance is actually telling us. Okay. So before we continue on to clustering, here are some questions I want you to keep in mind, and we're going to learn about the answers to these questions. But the first one, really try to understand when we talk about clustering is, what does it really mean to discover labels? Are these true labels that are some sort of universal truth, or is this our attempt to discover some reasonable cluster or reasonable group for these labels? And then also with clustering and dimensionality reduction, keep in mind that since we only have features without the actual known labels, how do we measure performance? If we have no correct label to compare to, how do we even know that the pathway we're trying to approach for clustering is even remotely correct? And then third, do combinations of features hold important insights? Can we actually get more insight by reducing something from 25 features to 2 features? That may seem counterintuitive at first, but there are insights to gain by simplifying your data set. All right, let's get started by approaching clustering. And the first clustering algorithm we'll learn about is k-means clustering. I'll see you at the next section.